Hi, Algebra 2. This is Unit 5, Lesson 4, and today we're doing our arithmetic series. So I just want to point out that this is not on the reference sheet. So on the Regents, you do get a reference sheet, and this formula is not on there. There are some other formulas that are that I will point out. But basically, an arithmetic series is the sum, meaning I'm going to add them all up, of all the terms of an arithmetic sequence. So remember, sequence is just a list of numbers. So an example of a sequence is 5, 6, 7, ... A series is the sum of all of those terms. So I would add 5 plus 6 plus 7 plus any of the other terms that came about. The formula that I can use to find the sum of all the terms, S stands for sum, so the sum of the total number of terms. So S of n divided by 2, and we'll define all of these terms, what each of these things is down below. Parentheses A1 plus AN. N is the number of terms. Okay, so if I have 10 terms, N would be 10. A sub 1 is the first term, and A sub n is the last term. So here's what you're basically doing. You're going to add the first term and the last term together. You're going to multiply that by the number of terms divided by 2. So I take the total number of terms divided by 2, and I multiply that by the first term plus the last term. So if I had 10 terms, I do 10 divided by 2, parentheses, the first term plus the last term, plus the 10th term. So let's look at this. Exercise 1. Which of the following is the sum of the first 100 natural numbers? Show the process that leads to your choice. All right, so let's write down. I'm going to use the formula S of 100 because I'm adding up the first 100 natural numbers. N, which is 100 because there's 100 terms, divided by 2. The first term, which is 1, and the last term, which is 100. Okay, my natural numbers are my counting numbers. They start with 1, and in this case, I'm just adding up all the numbers, the first 100 numbers. So 100 divided by 2 is 50, and 1 plus 100 is 101, and 50 times 101 is 5,050. Okay, let's find the sum of the 16 terms in the arithmetic series given by, and I started from -10, -6, -2, ... 46, 50. So you could basically see that I'm adding 4 each time in this arithmetic sequence, but I really don't need to know that. I want the sum of the 16 terms. So n is 16. So I got 16 divided by 2. The first term is -10, and the last term is 50. So -10 plus 50 is 40, and 16 divided by 2 is 8. So that's 320. So that's the sum of all 16 terms. All right, so it's really just a matter of using the formula. It can get a little bit trickier though, so we'll look at some trickier ones. Number 3, find the sum of the first 7 terms of the arithmetic sequence. Okay, so if I'm looking here, look at the difference. Let's find out what's going on here. I'm adding 3 each time to get from 2 to 5, to get from 5 to 8. I'm adding 3. Okay, my first term is 2, so I know that. And I know that I want 7 terms. The problem is I don't know what my last term is. I don't know what a sub 7 is. So I have to figure that out in order to use that formula. So I have to first find the last term. First find the last term. How do I do that? Well, a sub 7 equals 2, equals the first term, plus 7 minus 1, n minus 1, remember this formula from earlier on, times 3, times that common difference. So this is a formula we had back a few days ago. I do 2, the first term, plus, sorry, there should be a plus sign in there, plus, and then it's 7 minus 1, the n minus 1, times that common difference. So 7 minus 1 is 6, 6 times 3 is 18, 18 plus 2 is 20. So now I know my last term is 20. All right, now I can find the sum of all of them. So the sum of all 7 is 7 divided by 2, parentheses, first term, plus that last term, which I just figured out was 20. 2 plus 20 is 22, and 22 times 7 over 2 is 77. So this was a little trickier because you didn't know the last term. I had to figure out the last term by using that formula I learned in a previous lesson. Okay, let's look at the back right here. So exercise 4, I want to find the sum of the first 30 terms of the arithmetic sequence. Hint, first find the 30th term by using the formula. All right, so if I'm looking at this, so this is just like that last one, so we're going to try it again. The common difference here is 4 each time, so D is 4. All right, and I have to use my formula, and the formula is right here. That's what I just used on the other side. I didn't write it down though. I have to find the value of a sub 30. So a sub 30 equals the first term plus n minus 1, 30 minus 1, times that common difference. So 30 minus 1 is 29. 29 times 4 plus 3 is 119. So now I know the last term is 119. So the sum of all 30 terms, n divided by 2, 30 divided by 2, first term which is 3, last term which is 119. So that can just go right into your calculator, and I'm going to get 1,830. Okay, so we'll practice these tomorrow, but you should be practicing them now as well. All right, number 5, given the arithmetic sequence 7 plus 10 plus 13 plus dot 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 157, find the value of each. So first I want to figure out n, how many terms I actually have. All right, so to find n, I'm going to use my formula. A sub n equals a sub 1 plus n minus 1 times d. I can see right here that my common difference is 3. All right, so I'm going to plug this all in. I know the value of the last term is 157. I know the first term is 7. N minus 1 is just going to be, I don't know what n is, so actually that's going to stay n minus 1. And my common difference is 3. So now I'm going to subtract 7, and I get 150. Remember, I'm trying to solve for n. I want to find out how many terms there are. So I'm going to divide by 3. So I got 50 equals n minus 1. So n equals 51. So again, I'm using my formula in order to solve for this time n. Before I was trying to find my the value of that last term. This time I have the value of the last term. So in order to find out the sum of the sequences, eventually I'm going to find out the sum of the sequences, but in order to find out the sum of the sequences, you need to find out how many terms there are. So that's what I just did. So n is the number of terms. That was the first thing I had to find out. Now I can find the sum of the sequence. So the sum of the sequence is n over 2 a sub 1 plus a sub n. So 51 over 2, because now I know I have 51 terms, first term plus the last term. Okay, and that gives me 4,182. So you can see I'm just using these formulas to find whatever is missing. Before, I was missing the value of the last term. Here I had the value of the last term, but I didn't know how many terms there were. And the last one, Kirk has set up a college savings account for his son Maxwell. If Kirk deposited $100 per month in an account, increasing the amount he deposits by $10 per month each month, so this is an arithmetic sequence because he's adding on $10 each month, how much will be in the account after 10 years? Well, first let's take into account there are 12 months in a year, and I'm doing this for 10 years, so that's 120 months. Okay, that's going to be my n. Well, a of 120 equals 100, okay, because that's how much money, that's my a sub 1. So it's a sub 1 plus n minus 1 times my common difference. So 100 is the amount of money I put in the first month. 120 minus 1, which is 119, and my common difference, I'm going to be adding $10 each month. So 100 plus 119 times 10, 1,290. So that's the last amount of money that I'm going to deposit. What's the sum of all 120 months? It's 120 divided by 2, first amount that I'm depositing and the last amount I'm depositing. So this is just 60 times 1,390, and you can of course put this right into a calculator. And look how much money that is, $83,400. You know you're only starting off with $100 each month, but each month you're increasing it by $10. So look, that last month you're actually putting in $1,290. All right, so that is arithmetic series. We'll practice that tomorrow.